Okay, this section we're going to review section 2.3 on proportions. Of course, proportions is an expression of equality between two ratios, and they are going to be noted, of course, by an equal sign or a double colon. And then we'll show you an example here with the two double colons or the equal sign. So your proportions here, you have four numbers. Your means is the second and the third number, and your extremes are the outer numbers, which is your first and fourth number. Okay, so just remember your extremes, of course, must always equal your means. So a proportion is an expression of the equality between the two ratios, and a proportion is true, then the product of the means equals the product of extremes. So if you look here, you have your product of your means, 4 times 15 equals 60. And your extremes, which is the outer numbers, 3 and 20, equal 60. So both of these equal the same. If they do not, you must go back and rework the question in order to make sure that you get it correct. If they equal, you got your answer correct. Also, this is a good way to double check yourself on doing ratio and proportion questions. And this is that was just a generic way to write it. Proportions are frequently used to calculate, of course, drug doses in the pharmacy, and they use the ratio proportion method anytime one ratio is complete and the other is missing a component. So you have to know three parts, two of which is a ratio, and then the fourth one is an unknown that you're trying to find. So the ratio and proportion method is a conversion method based on comparing a complete ratio to a ratio with a missing component. These are the rules for the ratio proportion method. 3 of the 4 amounts must be known. The numerators, which is the top number, must have the same unit of measure. Same with the denominator. They must have the same unit of measure. So if you have grams on top for the numerator, must have gram on the other side. If you have milliliter on the bottom on the denominator on this one, you must have the same on this one. So here are your steps. Calculate the proportion by placing the ratios in fraction form so that the x is in the upper left corner. If you use the cross multiplication method, which I will be using, you do not have to worry about where the x is located. It will work out every time, but you'll have one more rule to make sure you go follow. But it's a simple one. 2, check that unit of measurement in the numerators is the same and the unit of measurements in the denominators is the same. Then you're going to solve for x by multiplying both sides of the proportion by the denominator of the ratio containing the unknown and cancel. That is the way they like to do it. I like to do the cross multiplication. So I'm going to just put cross multiply. I'll just put that. And then check your answers by seeing if the product of the means equals the product of the extremes, so you can check your answer. So just remember, when setting up a proportion to solve the conversion, it's really important to make sure that the units are going to match on both the top and the bottom. So what proportion is represented by these triangles is just letting you know that 8 to 12 and 4 to 6 are a ratio proportion. And if you want to check your answer to make sure they're correct, 12 times 4 is 48. 8 times 6 is 48. So they equal. So the ratio proportion method can be used to convert between units of measure. You can also use the ratio proportion to solve a conversion problem. So you put the unknown and the specific value that is to be converted on the left side of the proportion and the conversion factor on the right side of the proportion. So you use a conversion factor equal to 1 such as 1 gram equals 1,000 milligrams. And I'll give you some examples of this in just a few minutes. Conversion factor, of course, you have an equal to 1 that can be used when converting units of measure using the ratio proportion method. So just to give you some examples from your book, and we're just going to use some ratio proportions without any word problems for right now, and then we'll work our way up. So if you have x over 10 equals 20 over 40, okay, that is our problem. So you're going to cross multiply. Our rule for cross multiplying is whatever you multiply the x by always goes on the bottom. And I always put an x by it just to remind myself that it is, I did multiply that correctly and put it on the bottom. 10 times 20 would be 200. We're going to simplify that by taking out the 2 zeros, and then 20 divided by 4 is 5. Okay, our second one, x divided by 9, 5 divided by 10. So if you notice here we have 3 parts. 2 of them is a ratio. It's known. So we're going to cross multiply. X times 10 goes where? On the bottom, 10x. 9 times 5 is 45. 45 divided by 10 is 4.5. So if you had another one, we're going to do number 11. It is 14 divided by 23 over 27 to x. Cross multiply. 14 times x, I always multiply it by x, so it always goes where? On the bottom. 14x. 27 times 23 is 621. Divide that, and you should come up with 44.36. And again, this formula showed you that it doesn't matter where the x is at. As long as when you multiply 14 times x, you place that number on the bottom, it will always work out. So the x can be anywhere during a cross multiplication, but it must always go on the bottom when you cross multiply. So to set up ratios, proportions, and solve for x to answer the following, and then round your answers. Number 16, we're getting to a little bit more word problems. 72, and we're going to combine some knowledge that we've already gained from the previous sections. 72 is what of 254. So I'm going to give you, this is still going to be set up in a ratio proportion. Okay, but I'm just giving you a little formula to help you place the numbers. Excuse me, that's supposed to be of. So the number is, and that's why I put the number sign before the is. So whatever number it is before is goes over here. Of the number 254 goes underneath 72. And then we're trying to find what percentage. So we're going to have x percentage. And anytime you have a percentage sign on top, you have to have 100 on the bottom. That's our rule that we learned earlier. Then you're going to cross multiply. X times 250 is 254, goes on the bottom. Remember, because you multiplied it by x. 72 times 100 is 7,200. And if you divide that out, it should come to 28.35%. Our next one is 90%. That's number 17. 90% of what number is 44? Okay, so if you look here, we have 90, and then we know the percent, so it'd be 90 over 100. And remember our rule, number is would go on top of, so it is 44. So that's going to go on top. Of doesn't have a number behind it, so it's going to be your x. So you're going to cross multiply. 90 times x is 90, x, and it goes where? On the bottom always. 44 times 100 is 4,400. So 4,400 divided by 90 would be 48.89. Okay. Then we do one more here. Number 18, if we take 44% of what number is 100? Okay, we know we have 44%. Percent means 100. Okay, number is, or the is 100. So your 100 would go on the top. And you're trying to find of what number, so that would go on the bottom. So it's x. 44 times x is 44x. Always goes on the bottom. 100 times 100 would be 10,000. Okay, divide 10,000 by 44, it should come out to be 227.27. So there's some examples, but if you go by that little ratio formula that I showed you with the is and the of, the percent, that you should be okay. If you're having problems, let me know. Next, we're going to change the following weights using the conversion factor. So there's two ways you can do a conversion. I'm going to use the ratio proportion since that's what we're learning it in this chapter. Later on, I may show you the other one. But just remember, 1 gram always equals 1,000 milligrams. So our question for 21 is 100 milligrams equals blank grams. Okay, so that's the question out of your book. So we know we're trying to find x grams because this is x, and that's going to be over 100 milligrams. Okay, then we're going to use the known conversion factor that they give us. 1 gram equals 1,000 milligrams. So you may say, well, where do I put it at? Well, we know if we have grams up here on this numerator, we must have grams over here. So we have 1 gram. On the bottom, you have milligrams here, so it'll be the denominator. Okay, then you will cross multiply. Anything you multiply the x by always goes on the bottom. So x times 1,000 is 1,000x, and 1 times 100 would be 100. Okay, divide 100 divided by 1,000, and you should come up with 0.1 grams. Okay. We'll do a couple more, or maybe just one more here. Number 22. Let's see, do 247, here's the question, milligrams is equal to what in grams? Okay, and just remember x is what we're trying to find. So we know we have x grams over 247 milligrams. Again, they gave us the 1 gram to 1,000 milligrams. So you have grams on top here. We're going to put the grams here. Milligrams on the bottom, milligrams down here. Okay, cross multiply. X times 1,000 always goes on the bottom because you're multiplying it by x. 247 divided by 1. Excuse me, multiplied by 1, I apologize, is 247. Then 247 divided by 1,000 should be 0.247 grams. Okay, now we're going to do that same thing, but using weights. So we're going to use 1 kilogram equals 2.2 pounds. Okay, so our first question here is on, I'll put it up here, number 31, 6.3 pounds equals how many kilograms? So we know we're going to have x kilograms over 6.3 pounds. and then they give us our other known ratio, which is 1 kilogram. Remember, if you have kilograms on top here, you must have kilograms on the top here. These are your units. Pounds here, pounds here. 2.2. Okay, then you're going to cross multiply. X times 2.2 goes on the bottom because you multiplied it by x. That's our rule. 6.3 times 1 is 6.3. 6.3 divided by 2.2 is going to come out to be 2.86 kilograms. Okay. We'll do number 36. And that was 77.5 kilograms equals how many pounds? So we're going to have, we know we have x, and I just like to put my x on top, that's why I'm doing that. You don't have to put it there, but x pounds divided by 7.5 kilograms. And remember, they gave us on within the question that 1 kilogram equals 2.2 pounds. So if you have kilograms here, you must have kilograms here. Pounds here, you must have pounds here. Okay, so 1 kilogram equals 2.2 pounds. Cross multiply. X times 1 is 1x. Always goes on the bottom. And 2.2 times 7.5 is 16.5. Divide that, and you have 16.5 pounds. Okay, now we're going to do some ratio proportions looking at the drug labels. This right here is showing you, of course, the problem set with the drug label, and it's showing you that there's 50 milligrams in 1 milliliter. If it does not have a number, it's always 1. Okay. So we'll give you an example with number 41, and I'll write it up here. Okay, it says a drug is available as 50 milligrams per milliliter. Remember, always 1 though. Okay. If it does not have a number. The order calls for 100 milligrams, and we're wanting to know how many milliliters will you prepare. Okay, so we know our known ratio is 50 milligrams per 1 milliliter. And we know we're trying to find, we know we have our third known is 100 milligrams. You have milligrams up here, you must have milligrams on the other side. Okay, and then we're trying to find x milliliters. Okay, so what you do is you just cross multiply. 50 times x goes on the bottom because we multiplied it by x, it is 50. 100 times 1 would be 100. So then you can simplify it by taking out the zeros if you have an equal on each one. And then 10 divided by 5 would be 2 milliliters. Here is another label, and this is number 46 in your book. And of course it's telling you have 40 milligrams per 1 milliliter. So this is coming from number 46 out of your book. Okay. So a dose of, and I'm going to write this one in there, but you have a dose of 60 milligrams of gentamicin is ordered. The drug is available in 40 milligrams per 1 milliliter solution. How many milliliters are needed to provide the ordered dose? So set up your line. I always set up my lines first. And then I put my known ratio in first. But you can do that, or you can start with the x. So we know we want to find x. Let's start with the x to do the opposite. So we know we're trying to find x milliliters. Okay, because it tells us that in the question. So next we want to go to this side, and we're going to write in our known. If we have milliliters here, have to have milliliters here. Okay, So you have 1 milliliter to 40 milligrams. And then our third known is we need a dose of 60 milligrams. Okay. And we've checked our units, milliliters here, milligrams on the bottom, milligrams on the bottom. So we're good. So next we can cross multiply. 40 times x will be 40x. 1 times 60 is 60. Divide 60 by 40 and you get 1.5 milliliters. Okay. And again, we can, this is the same with all those questions. And you have a couple more on the PowerPoint, the pictures, but I'm going to just stop right there. I'll try not to go over 20 minutes on the video. If you have any questions, go back through each one of the sections and work the questions, because those questions at the end of the sections, you have the answers in your Appendix A in the back of the book. Okay. Once you've done that, you can give yourself a practice test at the end of the chapter, and I'll post those answers on Blackboard for everyone to check their answers with. And then you can go to take the Chapter 2 test. If you have any questions in the meantime, just send me an email. Thank you.